Hello, everybody. Oh dear, that will apparently loop unless I turn the loop track off. Learning as we go. Hello and welcome to the Bungalows for Bachelors late night learning. This evening we are going to be getting real excited about some really cool concepts, and then we're just going to poop on them because they might not be good ideas. And so I'm just hoping it's a roller coaster and everybody has a good time. That's what I'm hoping happens here. So let's just kind of get right into it here. First of all, who do we got in the comments? We got Mr. Will Stevenson joining here. He is excited, as you can see. He's ready to go. He's ready to keep me on time, and he is helping me learn how to do introductions as well. And oh, look who else we got. We've got the none other than the not red, not blue, but the green observer. Mr. Green Observer himself, welcome to the live stream. We're going to have some fun today. We're going to talk about some controversial things. I know Will's excited here. Look at that face. And you're just going to be blown away by how bad good ideas can be. So let's just kind of get right into it here. Well, actually, before we get into it, I'm going to plug myself in. So obviously, this is the Bungalows for Bachelors YouTube channel. If you're on here, then you know I have a YouTube channel. And you may know that I throw some free content out there whenever I can. I've got some projects that I do around the town, around the places. And I've got a garage to ADU project that's currently in the works. It's sort of on pause right now. And I've got some deck remodel thing going on. So I just kind of keep busy with doing some construction. I throw that stuff on there so you can learn about cool things on YouTube and just see some interesting projects. If you want to learn about construction, you don't know anything about it, then you can check out my school server, which if I'm smart, I would post in the comments right now while I'm talking, but I can't type and do that at the same time. So I'm not going to let some dead space happen, but I'll post it. I'll make sure that's available. Maybe one of these nice people in the chat will go look it up and post it for me. It's www.school.com/BFB success. Go there and you can check out my school server where I've got a home design program. If you need to be learning about how a house is built or how construction happens in general for residential purposes, check it out. You can learn there. That's one of my classes. And if you're a nerd and this advanced framing thing isn't good enough, then you can go check out the framing design program that I've created where you can learn about stuff. And I will make you a moderator when you know what? You said there was a way to do that. I'm going to see if I can figure it out right now because when's a better time than now to do anything? And I'm going to pop right over to YouTube. There should be a button that says make moderator. Let's see if that's true. I can put you in timeout. Oh boy. It's not showing me all the options. Oh, add as a moderator. I'm going to put you as managing moderator. All right. I think I did it. Let's see, I guess, what that means. And we'll keep moving forward here. Yeah, remove. Okay, so yeah, you're supposedly a moderator. I right click on my name. Fake links. Fake links. Uh-oh. Is somebody putting fake links out there? Somebody spamming my chat? Somebody putting scams? All right. So now that I've plugged myself on my own channel, I'm going to just jump right into it. Okay. So advanced framing, what does that even mean? Well, basically it's like regular framing, but it's advanced. It's only for advanced people. So what that means is people have been framing houses pretty much the same way for 80 to 100 years or so. Maybe, light frame, stick construction, 2x4 walls, 16 inches on center. Well, they used to be 24 inches on center, which is bad juju. But anyway, so pretty much the same stuff. 2 top plates at the top of the wall framing, some ceiling joists, some rafters, and some bracing. It's been pretty standard. But there have been a lot of different changes in standards, changes in materials, changes in how we build homes, changes in the way we design homes. And that's put a huge pressure on the way we build to basically build better. And in addition to a lot of new energy code requirements and things to try to make houses a little bit more efficient, build a little bit tighter. that has a whole bunch of ramifications downstream. So basically, we've got a system of regular framing. That's just kind of the way we've always been doing it. And now there's advanced framing, which is all these new ideas on how can we frame better, faster, more efficiently with less material and just make better homes that last longer and are more efficient. That's the idea, right? So a lot of this content can come from like some big guys on YouTube. Matt Reisinger is one of them, right? He uses a lot of Joseph Listaburek's science and new building science stuff in his home builds, and he does a great job with all of that stuff and builds awesome products, right? Now, Joseph Listaburek is a PhD, if I recall, and he has created like basically this building science movement, if you want to call it that. He's basically directed a whole bunch of his efforts and research and time to, oh my goodness. I'm sorry, I've got to stop for this. The Red Observer is also in the chat. So now I feel a little bit bad. Speaking of fake leaks, oh my goodness. I don't know where this is coming from, but I'm enjoying it. So we'll let that just kind of go back and forth between the Green and the Red Observer. Oh man. Okay. So yeah. So Joseph Listaburek, he's a guy. He just practiced a whole bunch, did a bunch of crazy stuff with like houses and stuff like that, and tested a bunch of methods, came up with a bunch of concepts, and those are the concepts that we're going to talk about today. So Green and Red Observer having a battle over here, a battle of the chats. I don't know if it's one person. I don't know who it is, but it's funny. The Red Observer is here to stay. Someone just making troll accounts. I love it. Okay, so advanced framing. So let's just kind of get into it here. So I am someone who has done structural engineering at a engineering firm for 2 years. I'm not a licensed engineer. This is not financial advice. And I'm just going to describe things that I think make sense with the math that I know how to use. And we're just going to kind of run with that as being my background, my legitimacy here. So let's just kind of pick the first one. So we got 2x6 walls, 24 inches on center, right? So what's the main purpose of this? Well, we used to build walls, and most people still build walls 2x4s, aka 2 inch by 4 inch nominally lumber. Those are the studs in the wall, right? They were 16 inches apart. That's just kind of a standard for how we built a lot of things. So why would you use 2x6 24 inches on center? Well, first of all, the whole premise is we want to take less wood. We want to put less wood in the wall so that we can have more insulation. And the less members of wood that we have to frame, the faster we can frame, right? If there's 24 inches on center, that means there's less studs, which means there's less wood we got to buy. There's less wood we got to ship. There's less wood we got to handle. There's less wood we got to nail. It's better in a lot of ways. So there we go. Will Stevenson plug in the school server, and yeah, that'll work. That'll work just fine. So the whole stud deal is all about how do you like remove the wood from the walls, right? So that's why we wanted like, well, what if instead of 16 on center, we did 17 inches on center, right? Well, that doesn't make a lot of sense because that doesn't work out well with the 2 foot and 4 foot standard materials we got. So let's just bump that up to 24 inches on center, right? So if we go to 24 inches on center and we try to use 2x4s, the load bearing capacity of the wall is significantly less than a 16-inch on center wall. So to make up for that, we say, well, okay, we'll reduce the number of studs, but we'll make each stud wider. Okay, so now our wall is a 2x6 wall, which means the bottom plate's 2x6, the studs are 2x6, the top plates are 2x6. The whole wall is going to be 5.5 inches of framing. So that is actually almost, I believe, twice the strength in terms of compression linearly along the wall. So a 2x6 wall, 24 inches on center is about twice as strong in compression as a 2x4 wall, 16 inches on center. So it's stronger. There's less studs. Each stud's a little bit bigger. I think mathematically it works out that on a whole house when you have lots and lots of wall length, Technically, it costs a little bit less or basically the same. So it's really the price is comparable. But that is the whole 24-inch on center deal. Now, it sounds great. I would like to handle less studs when I build houses, but is it as good as it sounds? Now, the first thing that you got to think about is the sheathing that's going on those studs. That is the trick here. So that's the real kick in the pants. I had a project go on where I had specified, and I was not the builder, but I was the designer. I had specified that we were going to build this house with 2x6s, 24 inches on center on all 3 stories, and they were stacked, and it was all hunky dory. In terms of the math, the math worked out, right? But it's not always about the math. So if we're going to frame a little wall here, and these are my studs, let's make this many. So if they're 24 inches on center, and then when I put sheeting on that and I stand the sheeting up vertically, which is typically what you're going to do, it's faster. I'm going to have a change a different color. I'm going to have one sheet on the left side, one sheet on the right side, right? Because these are 24 inches on center. Sheets are 4 feet wide in pretty much, every case. So I'm going to have one sheet over here, one sheet over here. They're going to get nailed to this stud in the common stud. Everything's great, right? So the sheets are going to get nailed off on the side. They're going to get nailed off down the middle, and they're getting nailed off on the other side. Now, if we compare that to a 16-inch stud layout, if we would draw with the marker, that's just going to be one panel's width. So that's a 4-foot width right there. So when the panel gets nailed like so, it's going to get nailed on the edge, and on the edge, it's going to get nailed twice down the middle of the panel in thirds. Okay. Now that's significantly more nailing and more connections and more stuff holding that panel down. Now, I used to think that people complained in the comments, people complained in different ways about how 2x6, 24 inches on center spacing the wall gets too wavy. And I thought originally that was because the studs themselves were not likely to be as straight, because the more you put closer together, basically what happens as soon as you put a sheet on it and nail everything down, the sheet tends to straighten everything out. But I don't think that's what the problem was. The problem is when you put these sheets on, and of course, when you put them on, they're supposed to have an 1/8 inch gap sheet to sheet, right? So they're not touching each other. Technically, there's room for moisture, expansion, contraction. It's a problem. Let's look top down view, right? So if these are come on, marker. If these are our studs top down and our sheeting is straight across the wall here, is that in the camera view? Basically, yeah, it is. Okay. What's going to happen potentially, and what happened to me in my experience, anecdotally, is that the sheets naturally were dry. They were stored and they were shipped, packed, and wrapped, and then they were moved into a dry space, and then they were installed, and they were still zip sheets, so they were coated, but they were in a much more moist environment. So what happened was the sheets were restrained on the studs, but they would actually bow out in between the studs and create a little McDonald's M there. So that was a problem when I went to go install the siding, because now I've got my wall bumping out doing crazy stuff. So the studs might not be the problem, but the sheets not being secured a whole lot often, well, maybe that's a problem. Now, and I don't know if it would make the solution better if you had your wall like this. It's a typical 8-foot walls. You're going to buy an 8-foot sheet, right? And you're going to install them vertically just because that's what people do. And it might be better if you took a regular 7/16 sheathing and you installed it. Let's see, 1, 2, 3. So these are 24 inch on center down here. So if you went halfway up the wall and installed it horizontally and then staggered your seams, right, and you went that way, maybe that would add enough rigidity across the studs to solve that problem. Maybe not. Don't know. I'm hoping maybe at one point I could have some money and take some tests and secure these things and test it dry, test it wet, see if this is actually a thing that can be fixed. But the only other way to fix it in my head is to use heavier sheathings, using thicker sheathings, which costs more money and it's not necessary. So the whole point of this is to build houses not necessarily cheaper, but more efficiently and like build better houses. And this just adds a whole bunch of cost. And if you can't afford to build it, then it's bad science. So that's the first problem is the whole 2x6 walls, 24 inches on center. We don't really have a good way to solve that rigidity problem right now as things are. So that's why a lot of the fancy building science builders out there are still building 16 inches on center because there's not a good way to combat that if you want your walls to come out nice and straight. And the people that are paying for these kinds of houses that are getting fancy building science details want straight walls. I can just about guarantee it. So let's talk about another one. Single top plates. What is a top plate? Well, when you frame a wall, this is not to scale. The bottom of the wall is a bottom plate. It's called the bottom plate because it's on the bottom of the wall. The next thing that you put on top of that is going to be your studs, not to scale. Let's put one in the middle here. I'm really good at drawing level. All right, so you got your studs in your wall. They sit on the bottom plate. Typically, if you're on a concrete foundation, that bottom plate's going to be treated, so it doesn't have any problems. And then on top, you're going to have a one top plate, and that is going to, the purpose of that top plate is going to be it's mirroring the layout of all of the, when I say layout, I mean the pencil markings, like when you're laying out your studs and your doors and stuff. Those marks that are on the bottom plate are copied over to the top plate so that when you take them apart and you lay out, you put your studs in and you start nailing everything together, your marks are on both plates and you can build the wall. And then when you stack a bunch of walls up against each other, all these ends over here are like just touching each other. So what we do is we take a second top plate and we usually extend it past, and then it's going to overlap some other wall over here, presuming that's a corner or something. And then we're going to nail them together, right? So that is how we're going to connect the walls together. And believe it or not, that connection is extremely important. And if it doesn't happen, then you basically lost what, well, my headset just turned off because it likes to do that sometimes, but that's not going to affect the audio. Now we have, oh my God. Someone has way too much time. We got Bright Green Observer in the chats as well. Oh my God. Okay. What have we started? Someone's created a whole bunch of unnecessary Gmails. That's what's happening here. Okay. So top plate splices. If you don't splice your top plates correctly together across the whole house, you're going to lose top plate continuity. And what that means is that all of the shear panels and all the stuff in your house, keeping it from getting racked over in a wind or earthquake event, if they're not connected to each other, they're not going to work and your house is going to fall apart. So that connection, extremely important. So what's this whole single top plate idea from the advanced framing dudes? Okay. The idea is you remove, oh, I'm sliding the whiteboard on the wall. The idea is you remove the top plate, the second top plate. And it's like, well, why do we need a second top plate? We've got one top plate. Why don't we just like use a metal strap that goes across both of them, right? Metal straps are fairly thin, right? We'll just nail it a bunch to here. We'll nail it a bunch to here. Boom, top plate continuity. Done. Now, here's the problem. The problem is that the math works out. The problem is that this can make sense. I believe if you buy a Simpson Strong Tie TP37 and nail it with regular like 10D nails, you achieve enough tension strength in that joint to be comparable to a wood lap. And it's the same in terms of its structural integrity. Now, I say this is a bad idea for myself because of the associated issues if you remove the second top plate. There's a lot of issues if you remove the second top plate. Not issues, just difficulties, making your life harder. So the first one is going to be that when we build houses, if you are building an 8, 9, 10, 11, or 12-foot ceiling, there is a pre-cut stud length that some manufacturer is going out and going chop, 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 chop perfectly so that all of those studs get delivered and they are already the right length, and you just put them in your wall and you nail it together and you stand it up. You're good to go. What most people don't know is if you go to the store and you buy a 96-inch stud or an 8-foot stud or an 8-foot 2x4, right? It's probably going to be 8 feet and a quarter inches long, or maybe 8.5 feet long, because what they're designed to do is they're designed to be cut and installed in an 8-foot situation. And what they don't like doing at the lumber mills is trying to make exact cuts, except for pre-cut studs, because those are specifically to be studs, right? So why is this a problem? Well, it's a problem because the pre-cut stud lengths that are associated with building these walls, let's say an 8-foot wall, are also associated with the drywall that goes on the inside of the wall and the sheeting that goes on the outside of the wall. So this is problematic because let's say we do a 8-foot wall. We'll just keep it simple. Okay. So you want to build an 8-foot wall. So you're going to buy 92 and 5/8 studs, I believe is the pre-cut length. Don't quote me on that. Okay. What's going to happen is that stud, I'm going to draw a cross section of the wall here. Bottom plate down here, single top plate up here, double top plate up there. Okay. So when you use a pre-cut stud with 2 top plates, the overall height of that wall, oh boy, I don't have the calculators in the phone and the color calculators over there. I'm done for. This episode is brought to you by Simpson Steel, Simpson Strong Tie. Yes, they sponsor all of my hardware. Not really, but that'd be cool because I could save some money doing that. So let's do some math here. Well, you know what? Each top plate is 1.5 inches, and I said 92 and 5/8. That seems about right. So if we add 4.5 inches to 92 and 5/8, that becomes 96 and 5/8. Wow, math on the air. Okay, I think that's right. Yeah, 1.5 inches plus 3 is 4.5. So 96 and 5/8. Bottom of framing to the top of the wall. 92 and 5/8 just doesn't sound right. Pre-cut stud, 8-foot length. Oh, 92 and 5/8. Well, I wasn't wrong. Okay, that's cool. So total length, right, is going to be 96 and 5/8. So what you might notice when you're installing sheathing on the outside of the house, presuming you've turned it vertically like everybody else does, because that's just how it goes on usually. The sheets are 8 feet tall, which happens to be 96 inches, which happens to be less than this number. So when you install your sheet, typically there's about a 1/2 inch or so that's hanging down below the very top of that second top plate. And that's typically not a problem because usually roof is going to overhang and someone's going to frame in some kind of soffit and it's going to cover that up. It's going to go away. No one ever cares, right? Or they just throw a piece of trim on the top of it, cover it up. Not a big deal. Drywall. When you go to hang the drywall, if you've got 96 and 5/8 a wall and your ceiling's on top of that, and let's say you hung a 5/8 rock on the ceiling, that probably went on first. So you lost 5/8 right there. So now you're down to 96 inches. And believe it or not, 96 inches is 8 feet. Divide that by 2. You can take 2 horizontal sheets of drywall and fit them on the wall. No cuts. It just goes on. That's what it's designed for. So, presuming I've got all this math correct, and you remove this second top plate, you just took 1.5 inches off of that number, which, stressing my poor little brain, is going to be 95 and 1/8. So now you saved yourself that top plate lumber, but you've got to cut down every single sheet that's going to go on the outside of your house, unless you want to push it down and hang it over your foundation. Interesting detail. Not the end of the world, but probably shouldn't. And on the inside of the house, you have to rip. And ripping drywall's not fun. You got to rip every single sheet of drywall, either on the top or on the bottom. It's not going to fit on the wall now. So you just created a whole bunch of extra work for yourself. And that's not fun. So that's one of the reasons why that's a problem. The other reason that can be problematic and more difficult to do a single top plate is stacking loads. Stacking loads, big load, okay? So when you frame a house, sometimes, well, in the old days, right, 2x4 walls, 16 inches on center, Your wall is going to look something like this there. Okay. Most roofs are going to be 2x6s and they're going to be 24 inches on center, right? So that's cool. There's no problem with that. So what that means is I'm drawing where the, oops, that was the wrong spot. Let's go all the way out here. Okay. So these are the rafters landing on the wall. And there's a second top plate there. Look at that. Look at that art. Okay. This is a 16-inch on center stud pattern. That's a 24-inch on center rafter pattern. You can see in areas A and B that the rafter does not land on, I got to get back to my stream, make sure I'm not missing chats here. The rafter does not land on the stud, but that's okay because there's two pieces of wood up there. Still, they're turned flat, but it's an amount of load. It's not a big deal. The load's distributed out to that stud and that stud from that rafter. And that's okay when you have two top plates. But when you remove one of the top plates, now you're taking maybe a significant load, especially you've got a tile roof or something like that, and you're setting it down on one flat piece of 2x4 or 2x6, and presuming that that's going to not deflect under that load and it'll transfer that load out. Like when you turn things flat, they don't tend to be strong that way. They tend to be kind of wiggly. So that's bad. We can't do that. So how do we avoid that? We have to stack the loads. So either you're going to go, if you're insistent upon using 2x4s on your wall, then now you have to go either 16 inches on center, keep that, and throw a stud below each of those. Or you're going to go 12 inches on center with your studs and waste a whole bunch of lumber and have a pain putting in insulation, and everything else is going to be a pain. Don't do that. Or you make your roof 16 inches on center and then spend a bunch of extra money in rafters that people don't normally spend. And it just sucks. So we don't want to do that. The alternative is to change your wall to 2x6s, 24 inches on center. But we already talked about why that was a bad idea. So we're not going to do that. And there's one more thing, because this is not bad enough of an idea yet. Metal hardware and the nails that secure it are a pain to work with. When you are a carpenter and you are trying to build things in a good world with good carpenters, you are building things to the tolerance of a 16th of an inch, like when you're framing, really. So most of the metal hardware out there is about a 16th of an inch, right? It's decently thick, but not super thick. You get into big beam hangers and stuff like that, you're up to 1/8 of an inch of metal thickness, and that's 2/16 of an inch, right? So you add nail head thickness on top of that, because the nail's not going to go through the metal; it's going to sit on top of the metal. And you're talking 1/8 of an inch, 3/16 of an inch sometimes in thickness that you are now dealing with. That's where no metal was before. So when you're framing, you got to account for that and adjust things and trim things, and it just becomes a pain. So presuming that you've switched to 2x6, 24-inch on center walls, and you've stacked your loads properly, what's going to happen is you're going to have a nice wall like this with a single top plate. And we use the metal when there's a splice in the top plate, right? So unless you're building your house out of walls that are only 24 feet long, and maybe you won't have any splices, but you still have splices at intersections and stuff. So you got splices. Okay. So let's draw more studs over here. So these were two separate top plate pieces of lumber, right? And they're going to connect right here. And of course, you've got your rafters coming down on that wall. And because there's a splice there, and you're a cool advanced framer, you used a metal hardware plate, TP37, and you slapped that sewing gun on top of there, and you nailed it down. Cool. Your plates are connected. Everything's good. It's going to be mathematically just fine. But this rafter is now sitting on a thing that none of the other rafters are sitting on. So you have to cut that bird's mouth 1/8 of an inch shorter, maybe, so that it planes out with the rest of the rafters on the top. Okay. And not only that, but if you've ever seen a TP37 metal plate looking top down at a splice in your plate, the thing is going to be most of the width of the wood. Okay. So you got nails over here, and you tried to set your rafter down right in here on that spot. Now, when we nail those down, we're toenailing them down per the code. It's in the code. Okay. So we're taking a nail and we're trying to get into the wood down there, trying to get into the wood down there, and then one on that side too. And that doesn't work very well when there's a freaking metal plate in the way. So just don't do it. Just don't. These things are things you don't think about until you're like, all right, I got the plate on. Time to put my rafters on. Oh, I put my rafters on. Oh, my roof's not planing out. Oh, now I have a lump in my roof. Oh no. Okay, so single top plates. That's how I feel about those things. Okay. Structural sheathing box headers. Structural sheathing box headers. What does that mean? Well, what's a header? Okay. If you got studs in a wall and you want to put a door in the wall, then you're going to remove some studs, at least one, and you're going to need to put something above it so that the weight that was coming down here is dispersed outwards and goes down into the studs next to it. That's called a header. All right, cool. That's a header. Structural sheathing box header. Okay, well, box is a box, and structural sheathing is OSB or plywood. It's the stuff that you're putting on your outside walls, right? So, what is a structural sheathing box header? It is someone who has used the structural sheathing that was already going to be on the outside of the house, and they've used it as the header strength material. Typically, a regular old header is going to be, for example, in a 2x4 wall, taking a cross section of the wall, right? We got two top plates because we figured out that one top plate was a bad idea. You got some kind of cripple stud, and that's going to land on top of a header package, which is typically just going to be 2x6 turned up, 2x6 turned up, and like a 1/2 inch shim of some kind. You're going to cut out a piece of sheathing or something that's going to go in between them. And that whole thing's going to give you 3.5 inches. And that is the header that starts the door opening below that, right? So the weight's going down, it hits the header, everyone's happy. So why would you do a structural sheathing box header? Well, the answer is for efficiency and science. If you put wood in the wall and no insulation, it's not very insulating because wood is only about R1 per inch and insulation is more. So we try to take the wood out of the wall and put in insulation. Well, you can't just take the structural thing holding the wall up out of the wall without replacing it with something that will hold the wall up. And so is born the structural sheathing box header. Okay, so what happened was someone said, "Hey, let's take the header out because we can get insulation in there now, and we'll have a nice, efficient house that might fall down." But someone said, "Well, you don't want your house to fall down. So what if instead, in that space where the header was, you put, there's some kind of plate, there's some kind of like bottom plate that defines the opening of the door, right? You got to have wood there somewhere. And instead, we use the sheathing on the outside of the house, right? The sheathing that's right there, that's the outside. And we cut it out in a rectangle and we nailed it on in such a way as to take the stiffness and strength of that sheathing and hold up whatever weight was coming down on the wall right there. And this only works for small openings. Big openings, not going to work. The sheathing is not that strong. Okay. So if we nail through the sheathing into these plates, a bunch, 3 inches on center to be specific, there's some reasonable strength we can get out of that thing. And we actually don't need to put a header in there. We have created a composite we have created this system of nails, sheathing, and blocks to create a header, right? That's cool. It's a cool idea. I like the idea. I might put it in some of my construction, But here's some of the problems you might run into. Okay. So the first thing, we're going to scale this up so that it's nice and easy to see here. Okay. So top plate, some cripple stud or something that gets you down to where the door header is. There's the bottom plate that's like the header thing to find the door space, right? Your door space is right here. This is a cross section of a wall. That's the cross section here, okay? Those are cross sections. So there is sheathing. Turn this so it makes a big line. Right there. Now, in terms of wall thickness, that sheathing was already there. So it doesn't really make a difference. Like, you're not going to have a lump in your wall. You're not adding anything extra. You're just being very specific with how you covered up that one spot over the door with the sheathing. So that's cool. That's cool. And if you got bigger openings, then there's actually specification in the IRC for how to nail on a piece of sheathing on that side too. And you get a pretty cool little system here. But then the problem is you just added sheathing to the inside of this wall and you were going to put drywall on it. So, like, do you sheathe the whole wall so you just bring the whole wall out a half an inch? How do we fix that? Well, let's talk about that. But before we talk about that, we're going to talk about the problems with this single-sided structural sheathing box header first. Okay. Problem with the potential problem with this design. Okay. You are nailing like that and like that. Your weight is theoretically coming down the wall, right? In a perfect world, things are nice and evenly distributed. See those three arrows? How nicely evenly distributed is that? That's cool. The strength member is on that side of the wall. It's on the outside of the wall. What happens if Jimmy Bob the framer is a little bit inaccurate with his one bird's mouth cut on his pattern rafter and copied that over to, oh, thank you for the well done cross section, Will. That was very nice of you. And this Bobby Joe guy or whatever his name was copied this pattern rafter over to all of the rafters on the house, cut them all, and they're just a little bit off. And the bird's mouth does something like that, right? And there's your rafter going up into your house. Now your weight's right here. Is that a problem? Maybe, maybe not. Depends on the thickness. Remember, there's drywall on this side of the house that is screwed to the wall as well. It's going to add some rigidity to this. But in a worst case scenario, what's going to happen here is these dudes are going to twist in the middle of your opening and crack all the sheetrock and have a bunch of problems because they were supported on that side of the wall, but they weren't supported over there where the weight was. Okay. So that's a fear of certain framers that I've run into with this detail. They don't want to build this because it doesn't seem sturdy enough to them. So how do we fix that? Well, I'm going to leave the blue there because it's going to be way too much work to erase it. But we can add the one on this side of the wall because now we've got both sides made a nice big compact box thing. It's evenly balanced. And we've got more servers. Okay, welcome to the chat. Blue but does not observe. Jimmy Bob the framer always messes up that pattern rafter system. I don't like Jimmy Bob the framer. And then we got one yellow observer. This is a new one. Welcome to the chat, one yellow observer. Man, y'all are really firing me up in the algorithm. I appreciate you. Look at all these fine colors. And then bright green observer still says, I'm still the best. The red observer says, we got the whole fam in a chat. You write what a red observer. And of course, Will is laughing because this is quite a chat that we've got going on here. So back to the science. We got this thing balanced out here, but we got sheathing, and nobody wants to sheathe the entire inside of their wall because now, how do you get outlets and stuff in it? It's just going to be a pain. So what can you do? Well, as the fantastic framers that we all are here at Bungalows for Bachelors, we know that we could let out the wall where the panel needs to go in. What does that mean? Well, it means you get out your multi-tool. It means you get out your chisel. It means you get out whatever saws you need to, and you are actually going to remove half an inch of material in that whole spot, wherever the thing is going in, and you're going to set that piece of sheathing into the wall framing. So now everything's flush and you're good to go. Now, that's a solution. You can get tons of insulation in there. Remember, you got to put the insulation in there before you put the sheathing on both sides. Otherwise, you got to drill a hole and like spray it in or something. I don't know how you're going to get it in there. Okay, so you got to put insulation in there first and probably take a picture because some inspector somewhere is going to be like, I don't see there's insulation in there, because that's how inspectors talk. And you're good to go. Now, I have done this on a practice wall where I was timing myself, framing, doing some things. This is a significant consideration in terms of time, getting the wood notched and cut out of that wall, because now you've got to notch the top plate, notch this plate, notch this one, notch the jack studs that are on the sides of the opening. It's just a big mess. Okay. So again, the whole premise is we're advanced framing things. And yeah. Wow. The red observer, one yellow observer, bright green observer, and blue but does not observe all said you got it, dog. I appreciate you guys. Y'all are winners. We're all in this together. So you can do that, right? Doesn't sound like this advanced stuff is super duper helpful, but like I might do this one. I might invest that time on my projects that I am going to keep, that I'm real estate investing in, that are going to benefit me and my energy money. I might do that. I might invest that time because I care. Will an investor care for some flip project? No. Will some home builder care for some client that doesn't pay them enough money? No. These are things that, oh man, I keep dropping my eraser. These are things that are tricky, that add a lot of complication. Blue dog, blue can hide that comment there. Okay. So where are we at? Structural sheathing box headers. Oh, so that's that problem. Okay. Header hangers. You ever heard of a header hanger? Yeah. It's a hanger for your header. Not to be confused with a header for your hanger. Get it? Okay. So in a door opening, you're going to have 2 jack studs. You're usually going to be nailed to the king studs. Your header is going to sit on those jack studs. And you're going to have some cripples maybe, right? Typical header. So the header hanger is another fantastical idea introduced to the world. I think Simpson Strong Tie makes some. And the purpose is to transfer the load from the header to the king studs and remove the jack studs from your wall assembly. Remember, less wood on the wall is a more efficient wall, and it's less wood that you had to install, y'all. So that's the idea. The header hanger is basically a metal hanger that's going to get nailed to the header and nailed to the king studs. It's going to transfer that load over there. Now, again, remember, we talked about adding metal hardware to walls. It's adding thickness. So now on this side of the wall, you've got an 1/8 of an inch sticking out. On that side of the wall, you got an 1/8 of an inch sticking out. The drywall is going to have a lump. Your sheathing is going to have a lump. You try to put any nails through that hanger from the outside, when you're doing your siding or trim, and it's just going to go, and it's going to blow up your material. It's going to blow up the nail. It's going to just cause a mess, and it's going to be a pain. I don't personally think I'm ever going to be doing that one. It just doesn't strike me as being a great solution. The only way I would consider doing that is if I let out the header and was able to push that metal into the wall and make it flush out. I would consider doing it there. All right. Some cool ideas, really. Cool ideas, okay? So removing unnecessary cripples. What is a cripple? Well, typically a cripple is going to look something like this. There's going to be 2 legs. They're usually hunched over. Their arms are going to go out, and they have a walker with tennis balls and wheels on the bottom. And they're sad because they're a cripple. Okay. But in the, terms of like construction, the cripple stud is going to be Bottom plate. Let's see. What are we doing here? We got a door because it's all about openings, right? So there's a door. That's a window. Let's do a window. Okay, so we got king stud for the window, king stud for the window. And there's going to be a jack stud for the window next to it. Header for the window goes across. There's going to be cripple studs above. And there's going to be a sill and cripple studs at the ends of the sill and on layout. Okay, so the layout cripples are in there so that you can have nailing for your sheathing, so that you can have support for the sill. Like this is a window, its nailing flanger is going to get nailed to the outside of the wall all the way around. The weight's not transferred to the sill. The window doesn't sit on the sill and give its weight to the sill. However, things do happen. Occasionally you drop something on the sill while you're framing and it like kicks things around, right? You want these openings to be nice and square if you can. So removing extra cripples. Also, they will add cripples above the jacks as well on both ends. So that's just typically how people do that. So removing extra cripples that we don't need. These ones up here, they're not contributing anything. You're probably never going to have a problem if you remove them. So just remove them. Ta-da. No big deal. The only thing they're really contributing is somehow if this header were to try to get twisted or something in its place, the cripples is blocking it in, so the ends can't rotate, but it's not super helpful. Okay, now the bottom sill. Again, the cripples that we don't need are the ones that are not on layout. They're just on the ends. Now, this is somewhat more controversial because, again, if somebody drops something right there on the end and all you've got holding that sill to the jack stud is the nail that you put in sideways. What happens when you create a shear connection? This is called a single shear nail thing. So you do that. If you were to pull on this joint, right? You're going to pull like that. What you're going to do is this nail is actually going to shift like that. It's going to do that way before anything fails, but it will move because what's happening is you're technically crushing some of the wood fiber. That is, let's see, you'd be crushing the wood fiber here and here on both sides of that, and it would just get squished. It would move, right? If you've ever framed a house, you know that when you put a nail in something, that doesn't mean that it's in its final location. Frequently, you put a nail in something to get it to stop moving so that you can whack it into its final location, at which point you put 10 more nails in it so it doesn't go anywhere. You don't need 10 nails, but that's the idea, right? So because of that premise, if you nail this off and you don't have a block below it, the block's going to stop something from really moving it. But, you don't really need it. So if you're careful, again, it's not a big deal. You can do that. Now, what's the other problem with removing extra cripples and removing all this extra lumber? Again, is the trim carpenter who comes behind you, who's going to install wood around this opening, maybe put some casing trim on the wall side, like around the opening. He's expecting a certain amount of wood to be there. And if you're removing extra pieces of wood and adding metal hardware and stuff, it's just like he can give him a bad day. Like when you're that guy, when you're building something for yourself, which is what we try to do here at Bungalows for Bachelors, it matters when you're that guy. So that's why. Don't make your life more difficult down the future. Will Stevenson says, rip old people, LOL. Yeah, sucks to be old, but we'll all be old one day and it'll suck. So let's see. And then, okay, the last topic here, building dimensions to accommodate materials. This one is both good and bad. Building dimension to accommodate materials. We're going to talk about the roof and the wall, but we're going to start with the wall. Okay, what does it mean, building dimensions to accommodate materials? Well, most of the sheathing products that we have out there are 4 feet wide, okay? And they go up vertically. The stud layouts we use are usually 16 inches on center, sometimes 24 inches on center. So when you're designing a house and you make a box, it wouldn't be very smart to make it 11 feet by 13.2 feet. Okay, what's going to happen here? Well, when you're sheeting this wall, you're going to go 1 sheet, 2 sheet, 3 sheet, and you're going to have 3 feet extra from this 11-foot thing. Now you can use 1 foot of that on this side, right? But now you have 2 feet of sheet that's theoretically not going in. Well, let's see. If you do it over here, then you would go 1, 2, let's see, 3 would get you to 12, and then 1.2. So you could use up 1.2 of that sheet, but like, again, just wasted material. So when you're doing that was a top-down view, by the way, of a floor plan. When you're doing your wall design, your room layout and stuff like that, if you can keep exterior framing building dimensions to 2-foot increments, or maybe 1-foot increments if you really got to push it, then you're going to waste less material. Now, I will agree with that all day long because it just, and like laying out, if you got a 24-foot wide wall, your stud pattern is the same. It's consistent across anywhere in the wall. It's the same if you pull from the right side of the wall or you pull from the left side of the wall, everything's 16 inches on center. So that matters because if you build something that was let's say an 18-foot wall, that's not easy. That's not directly divisible by 4. What's going to happen is if you went 16 inches on center, you started that pattern from one side of the wall. So you're going to frame it. Cool. You're going to put your sheathing on. Cool. Maybe put your house wrap on that. Now you can't see your sheathing anymore. And if you don't remember what side of the wall you pulled 16 inches from, you just go inside and look, or start driving nails until you find your pattern through the wall again, because you got to put the siding on and you want the siding to hit the studs. So if you build a 24-foot wide wall, then it doesn't matter what side you go from, you know that your pattern is consistent. Okay. So that's the wall side. So let's talk about the roof. Okay. And this is the one that I disagree with. You should not select roof slopes to get correct material estimates. And here's what I mean by that. The idea, it sounds nice, but it's not applicable. It's not applicable. You can't do this effectively. If you are going to build a house and the house has a roof, you're going to put sheeting products on the roof. Those are 4 feet wide too. So let's say that this is your house. You're going to go 1 sheet, 2 sheet, and let's say there's a little half a sheet there or something. Okay, so the same as on the other side. 1 sheet, 2 sheet, half a sheet. So when we build houses, we specify and design roof pitches that are in factor of 12, right? So it's going to be a 3/12 pitch, 6/12 pitch, 8/12 pitch, a 1/4 pitch for a half roof, maybe, or for a flat roof. Okay. So we just do things in increments of 12. That's just because we do. That's how all the tools are laid out and designed to work with. That's what we do. We don't do it in degrees. We just do it in 12s. Okay. 12th of a foot. Rise over run. So the point of the roof material deal was basically, instead of making your roof a 6/12, why don't you make your roof whatever degrees it needs to be to land, like, let's say 2.5 sheets or 3 sheets wide, right? So you're selecting roof dimensions that are based on like the material you're going to use. And here's why I think that's a bad idea. One, because when you're actually doing this, by the time you get to this point, you've got to be darn sure that all your dimensions are already good. 2, everybody does soffits a little bit differently. The overhang of the house, depending on where exactly that sheet ends or starts, is going to determine where it ends at the peak. Also, sometimes the peak is vented. Sometimes it's not vented. Okay, so that's just moving all these things around. Like, there's just way too many factors to try to guess exactly how many sheets you're going to need for the roof. So that's just seems beyond me to try that. So I will not be doing that. But again, you do what you want. You're all adults here. So those are pretty neat ideas. Like, those are some cool concepts that can apply and do certain cool things. And when you have full control over what you're building, you can decide to do all of those if you want, accepting the ramifications of what they are. If you're really like in love with this concept, you can do it. And more power to you for trying. But these are things that I have seen and experienced and thought through that are just not worth it. And there are some other uh, details that kind of go along the same category, but it's all the same theme, right? So yes, Bright Green Observer has it exactly correct. It sounds like a lot of math and room for error to save a couple bucks. Yes. The principles are you're trying to save energy by having less wood in the walls, save a little bit of effort, right? A lot of math with little room for error. Correct. So, you know, when I approach building, I would rather build a building that is airtight and super air controlled and not that thermally efficient, because the return on investment on keeping the air in your house is 10x the return you're going to get if you manage to like leak a bunch of air, but somehow your walls are thermally efficient, right? So the thermal efficient, like keeping the air in your house is way more important than not letting the heat radiate through your walls too fast or let the heat come in too fast. Like it's just not even close. So like if you build a loose house and it's really air leaky and your walls are super duper thermally efficient, well, your walls aren't going to do jack because the air that you're trying to control the temperature of with your thick walls, that air is getting lost because it's going outside. So control the air, man. Like if you're trying to do this on like a money cost perspective, just control the air and like build an average wall and you'll be way better off. Red Observer, single medium cost versus long-term bleeding cost. Red Observer has some good financial ideas. Yes, good, exactly. Good wording. Green Observer, need a proper air exchange system if you are going to build airtight to avoid CO2 buildup. Yes, Green Observer, I bet you could tell us all about that. Correct. Yeah, if you're going to build an airtight enclosure, you better know how to get fresh, clean air in there, filtered. And yes, it does cost money to do that. So all expenses. And Blue Dot has observed that the Green Observer has a good observation. And he said, or she, I shouldn't assume, they said 100%. All right, y'all. That's what I got. I appreciate y'all hanging out in the chat, causing trouble. Shout out to everyone who decided to show up today. We've got the Blue Dot does not observe. We got the Green Observer, the Red Observer, the Bright Green Observer. We got Will Stevenson. We got the One Yellow Observer. And I think I got all of them. I appreciate y'all joining me this evening. I hope you learned something. And if you didn't learn anything, that's okay, because you were probably never going to try to do advanced framing anyway. But I appreciate you joining and coming on and supporting the channel. So, thank you guys for coming on. Let me go ahead and take us on out. I will see you dudes, and maybe not dudes, later.